Hello students, in the previous lesson we have studied about the introduction of matrices and types of matrices. Now today we are going to learn the basic operations of matrices like addition, subtraction, multiplication and to find the inverse. So today we will cover these three things: addition, subtraction and multiplication of matrices. Now, in the first two, addition and subtraction, the condition is the matrices to which we are going to add or subtract, they must have the same order, or we can say they are comparable matrices. So, for addition or subtraction, order of matrices must be same. Means let a matrix is A is a matrix of order m by n. B is another matrix of order p by q. The addition or subtraction is possible. Addition or subtraction is possible only when m is equals to p and n is equals to q. Because in the addition or subtraction we are adding the corresponding elements. So the order must be same, because if order is not same, we cannot get the corresponding elements. So it will be not possible to add the matrices or subtract the matrices. So we are taking one example to understand this. Find a plus b and a minus b if matrix A is equals to 3, 5, 7, 8. Another matrix B is 2, 3, 9, 5. Here we can see the order of both matrices is same. Matrix A is of order 2 by 2, matrix B is of order 2 by 2. So order of A is 2 by 2 and order of matrix B is also 2 by 2. So we can add or we can subtract these matrices. So A plus B is equals to the first matrix 3, 5, 7, 8 plus second element 2, 3, 9, 5. Now see the corresponding elements. Element of first row and first column added with element of first row and first column. So it is 3 plus 2. Element of first row and second column, this one. Element of first row and second column, so it is 5 plus 3. Element of second row and first column, element of second row and first column, so it is 7 plus 9. In the same way it is 8 plus 5. So the matrix A plus B will be 5, 8, 16, 13. In this way we can add the matrices. Now we are going to subtract. It is 3, 5, 7, 8 minus 2, 3, 9, 5. It is 3 minus 2, element of first row and first column. Here it is 3, here it is 2. Now element of first row and second column, that is 5 minus 3, 5 minus 3. Here it is 7 minus 9 and 8 minus 5. So the difference of these matrices is 1, 2, here it is minus 2 and it is 3. So in this way we can find the addition or subtraction of the two matrices. So it is very simple. Now the third basic operation is multiplication. There are two types of multiplication. First one is multiplication of a matrix by a scalar. Multiplication of a matrix by a scalar. In this condition, if we multiply a matrix by a scalar, then that scalar multiplies with all the elements of the matrix. For example, if matrix A is 3, 5, 7, 2, and we want to multiply this matrix by 3, means we have to find 3 times of A. It is 3, 5, 7, 2. All the elements of this matrix will multiply by 3. Then the matrix 3A will be 3 into 3, 3 into 5, 3 into 7, 3 into 2, and the resulting matrix will be 9, 15, 21, 6. So this is the matrix obtained after multiplying by this matrix by 3. Means if A is a matrix Aij of order m by n, then PA is equals to Bij of order m by n, where Bij is equals to P times of Aij, and P is a scalar. So in this way we can define the multiplication of a matrix by a scalar. So if Aij is an element of matrix A and order of this matrix is m by n, if we multiplying this matrix by P is a scalar, then P into A is equals to Bij. Bij means the new element of this new matrix after multiplying, but Bij will be equals to P times of Aij, means corresponding element is multiplied by P, where P is a scalar quantity by which we are multiplying the matrix. Order of this matrices, the matrix which we have multiplied and the matrix obtained after multiplying, both are same. Order must be same. Okay. Now the next topic is multiplication of a matrix by a matrix. Now, matrices matrix multiplication or we can say multiplication of a matrix by another matrix. It is a very important topic, multiplication of two matrices, and very useful in the next chapter also, that is determinant. So let us start. First of all, what is the condition in which we can multiply the matrix and how to multiply the matrix? So if there are two matrices A and B, order of matrix A is M by N, order of matrix B is P by Q, means in matrix A there are M rows and N columns. In matrix B there are P rows and Q columns. Multiply of A and B means A into B is possible only when number of columns of A and number of rows of B are equal. So A into B is possible only when number of columns of A is equals to number of rows of B. This is the necessary condition. If number of columns of first matrix and number of rows of second matrix, these are not equal, then we cannot multiply the matrices. Then the multiplication is not exist. So if two matrices are given and you have to ask to find the multiplication, then first of all check this condition. If we change the product or reverse the product like B into A, then what will happen? If B into A, then first of all to check the columns of B and rows of A. If these are equal, then B into A is possible. Okay. So B into A is possible only when number of columns of B is equals to number of rows of A. Sometimes A into B is possible, but B into A is not exist. So the multiplication of matrices is not commutative. Sometimes the result may be equal A into B and B into A, but it is not always. So we can say the multiplication of matrices is not commutative. Now, another thing is, we have seen that to find the AB, we have to check the order. Order of A is M into N, order of B is P into Q. Then these two numbers must be equal. This is necessary condition to find A into B. For A into B. Now, after the multiply, the new matrix will be of order m by q. The matrix obtained by the multiplication of A and B will be of the order m by q. Means the resulting matrix or product of matrix will be of order m by q, where m is number of rows of A, q is number of columns of B. These are two things. Now we are proceeding how to multiply the matrices. Let A is a matrix of order m by n. B is another matrix of order n by p. You can see the number of columns of A and number of rows of B are equal, so we can multiply here, and the product AB is represented by C its order will be m into p. Order of the product is m into p. Now we are going to define what is the Cij, how to obtain the element of the product with the help of the elements of the given matrices. So here Cij is equals to AI1 multiplying with B1j plus AI2 B2j AIN B and J, or with the help of sigma notation here R equal to 1 to N AIR BRJ, where I is less than or equal to M, greater than 1, greater than or equal to, and J is less than or equal to P, greater than or equal to 1. Means the first row multiplied with first column element of second row with second column the corresponding elements. By taking one example, we can clarify it is. Let us it is A11, A12, A13, A21, A22, A23. This is a matrix. Another matrix is B. It is B11, B12, B13, B21, B22, B23, B31, B32, B33. First of all, check the order. Order of A 2 by 3, order of B 3 by 3. So number of columns of A and number of rows of B are equal. So multiplication is possible. So A into B is possible. Now to find A into B, it is A11, A12, A13, A21, A22, A23 into B11, B12, B13, B21, B22, B23, B31, B32, B33. Now, as per the definition, ith row and 1 is the column. The element of ith row and 1 column multiplied with the element of first column and jth row of second means here the element whose address is A11 means first row and first column. So we will multiply with first row with first column corresponding element. First row multiplying with first column. So here it will be A11 into B11 plus A12 into A21 plus A13 into B31. In the same way, when we are going to obtain the second element means element of first row and second column, then we will multiply first row with second column. So first row is A11 into A12 plus A12 to B22 A13 into B32 like this. Now the first row multiplied with third column, so because we do not have the space here, so we shall take another example to clarify this by taking some numbers. Taking a matrix like 3, 2, 1, 5, 7, 3. Another element matrix B is 2, 5, 3, 7, 9, 8, 2, 1, 6. Now order of A is 2 by 3 and order of B is 3 by 3. Number of columns in A and number of rows in B are equal, so multiply is possible. So we are going to find the product of these two matrices. Three, two, 1, 5, 7, 3 into 2, 5, 3, 7, 9, 8, 2, 1, 6. Now, first row multiplying with first column. First row multiplying with first column. So 3 into 2 plus 2 into 7 plus 1 into 2. Now, first row is multiplying with second column, 3 into 5, 2 into 9 plus 1 into 1. Now, the first row of first matrix multiplying with third column. This is the first row multiplying with third column. So it is 3 into 3 plus 2 into 8 plus 1 into 6. Now, in the same way, in the first row we have multiplied the first row by first column, then second column, then third column. Now the second row multiplying with first column, and 5 into 2 plus 7 into 7 plus 3 into 2. Now it is second row multiplying with second column, 5 into 5, 7 into 9, 3 into 1. Then the third row multiplying with third column, it is, sorry, second row multiplying with third column, 5 into 3 plus 7 into 8 plus 3 into 6. Now, by calculation, we can find it is 3 to the 6, it is 14 plus 2, it is 15, 18, 1, 9, 2 is just 16 plus 6 here, it is 10, 49, 6, it is 25, 63, 3, 15, 56 plus 18. Now add the numbers to find the various elements. It is 6 plus 14, 20, 22. It is 15 plus 18, that is 33 plus 1, that is 34. Now 9 plus 16, that is 25, 25 plus 6, that is 31. Now 10 plus 14, 59, 59 plus 6, that is 65. 25 plus 63, 88 plus 3, that is 91. Here 15 plus 56, that is 71. 71 plus 18, that is 89. So this is our A into B. We have find by multiplying of. Now check what is the order of A into B. So its order is 2 by 3. Its order is 2 by 3, means it is equal to number of rows of A and number of columns of B. So multiplication is only possible when the number of columns of first matrix, which is called pre-multiplier or prefactor, and number of rows of second matrix, that is called post multiplier or post factor. Okay, so if we are finding A into B, then each called A is called pre-multiplier and B is called post multiplier. Also called prefactor, it is called post factor. So multiplication is possible only when the number of columns of pre-multiplier and number of rows of post multiplier are equal. If not equal, then product is not exist. We are taking one example to clarify this. Question is, yes, question is, if matrix A is equals to alpha, beta, gamma minus alpha is such that A square is equals to I, then option A is 1 plus alpha square plus beta gamma. Option B is 1 minus alpha square plus beta gamma equals to 0. Option C is 1 minus alpha square minus beta gamma is equals to 0. And option D is 1 plus alpha square minus beta gamma is equals to 0. This is a multiple choice question. We have to find which option is correct. So, in this question it is given that A square equal to I. I have already told you that I means the identity matrix, and identity matrix means whose diagonal elements are of 1 1 and all other elements are 0. So, and A square means A into A. So, placing the values, matrix A is alpha, beta, gamma minus alpha. Again, the same values, and the result means the product of two matrices is of the order number of rows of first matrix and number of columns of second matrix. It means it is 2 by 2 order unit matrix. Now multiply these matrices. First row multiplying with first column, so it is alpha into alpha square, sorry, alpha into alpha, then plus beta into gamma. Now the element of first row and second column means we have to multiply first row by second column. So alpha into beta into minus alpha. Now the element of second row and first column, so multiply second row by first column. So gamma into alpha plus minus alpha into gamma. Now the element of second row and second column, so multiply second row by second column. It is gamma beta plus minus alpha into minus alpha. It is equals to 1001. You can see here it is alpha square plus beta gamma. Here it is alpha beta minus alpha beta, gamma alpha minus alpha gamma. It is beta gamma minus plus, that is alpha square. It is equals to 1001. The next step, we have alpha square plus beta gamma. Here alpha beta minus alpha beta, that is 0. Here gamma alpha minus alpha gamma, it is also 0, and it is alpha square plus beta gamma. Now we can observe that these two matrices are comparable matrices and equal matrices. If these are equal matrices, then we can compare the corresponding elements. Here the diagonal elements are same, here also same, in the unit matrix. So compare these. So alpha square plus beta gamma is equals to 1. So we can say that alpha square plus beta gamma minus 1 is equals to 0. So alpha square plus beta gamma minus 1 equals to 0. But here in all the options 1 is given positive. So you can change this by multiplying by minus 1, then it will become positive 1 minus alpha square minus beta gamma is equals to 0. So 1 minus alpha square minus beta gamma, 1 minus alpha square minus beta gamma. So option C is correct. So I hope that the basic operations of matrices are clear. Now other things, that is the transpose of a matrix and skew and symmetric matrix, and by the row transformation elementary operation method we shall discuss later. Thank you.